All right, here we are working through the concepts of simple and compound interest. Interest is a charge or sometimes a benefit that happens when you either deposit money on an account or sometimes when you borrow money, you are charged interest. So interest is just like a fee that is given towards money when it's deposited or borrowed. I think you've heard about interest before on car loans, house loans, things like that. So in math, there are two formulas that help us deal with interest. One is called simple interest, and that's the one we're going to deal with first. And then about halfway through, we'll deal with another thing called compound interest. And you don't really have to have a lot of understanding about what those different words mean. The best way I can give it to you is this. Simple interest is very straightforward and the formula looks simpler, but you have to be very thoughtful when you work it. Compound interest looks a little more complicated when you run the interest formula, but for us, it usually ends up being a little easier to do well. So with that in mind, here's a simple interest formula. The I stands for interest, meaning when you work this formula, it will tell you how much interest you owe or how much interest someone owes you. The P stands for principal. Principal is the amount of money that you start with in a given story. So if you deposit $1,000 in a bank, your principal's $1,000. If you borrow $2,000 for a boat, your principal on the loan is $2,000. It's just the starting amount of money. R means the rate, and the rate is going to be an interest rate, but we call it rate so we don't get it confused with interest. So rate right there. Rate will be written in a percent, like this 4%. But as you guys might remember from last week, whenever you deal with percents, percent means divided by 100. So 4% means 4 divided by 100, which would really be 0.04. So when we use the rate, we have to write it in its true form of a decimal right there. Time means how long is this operation going on, whether it's a loan or a deposit, and it always has to be given in years. So if you end up with something that says like 12 months, that's the same as 1 year, and you'd use the number 1 in your formula. If you end up with 36 months, that's 3 years, and you would use the number 3 in your formula. We use a framework called Formula Substitute Solve that most of you have seen before. And in this framework, you write the formula at the top in this box, and then right underneath it, you plug in all the numbers that you have available. Meaning, interest number, I don't have one. Principal number, I do, it's 600. And then the rate number for the R right here, I've got one of those too, but when I put it into my formula, I have to put it in as a decimal, which is why it's a decimal right there. Third number, do I have a T for right here? I do, and it's 2 years, and so I just put it right there. And then all I have to do is calculate all the way through, type in 600 times 0.04 times 2, and the answer in the calculator will be the amount of interest that happened in this story. So take a minute to calculate that. Pause if you need to. And then I'm going to tell you that this right here is the number you should have gotten, $48. That's the amount of interest you gained in that story. But there's another number up here, and this number is your total amount of money in this story because you deposited $600 at 4% interest for 2 years. So at the end of 2 years, the bank paid you $48 in interest, but you have $648 in your account because this number right here is your total. It's the amount you started with, the principal, plus the interest, therefore 648.
All right, so we have another given set of information. We have a principal amount of $640. We have a rate of 3.25%, and we have a time of 2 years. So as Mr. Campbell mentioned, we have our same formula that we've plugged into our formula line here. And the only number we need to worry about changing before we put them into our formula is this rate right here. So just like Mr. Campbell said, anytime you see a percent, this is a percent out of 100, so we need to divide, which would then leave us with 0.0325. And when you substitute your numbers into your formula, just like we have here, we have a P, an R, and a T, so our I is still going to be there on our formula, but what we will... So we have our 640 that has our principal amount. We took this number here and we put it into our formula. We then have our rate of 0.0325 that we converted to a decimal, and we have our time of 2 years. So once again, we're taking each of our numbers and multiplying them across. If you notice, on the last one that Mr. Campbell did, there was multiplication signs in between, and that was just to show you that there are multiple ways of demonstrating or showing multiplication, and if you just see parentheses, that is also an indicator of straight multiplication. So when you multiply those across, take a moment to do that, you will see that you will get your $41.60. So when you go and add your principal amount of $640 to your interest of $41.60, you will get your total amount, which is $681.60.
The added bit of complexity in this one is that your time is in a more difficult format. It's in a fraction. So here's all you have to do with this. Before you get going, just turn your time into a decimal. 3 1/4. You can use a calculator. You can just use a little thinking skills. That 1/4 would be 1 divided by 4, which is 0.25. So 3 and plus 0.25 is going to be 3.25, and that is your number that goes in for time. So once again, you write interest equals the principal times the rate, 0.0675, times the time, which is 3.25. I'm going kind of quick because you've seen some examples of this before. You run it all out, you'll get an answer. The only difference is you had to work with this fraction. The answer you should get is $187.57, and then you throw back in the principal you started with, and that's your total amount in this story. Oh, I'm going to do this one too. So this one also has a problem with the time, but it's not a fraction problem, it's a months problem, which will happen occasionally. If I tell you that something took 12 months, that's the same as 1 year, right? We're kind of used to that. So if I said, well, 12 months equals how many years? Well, 1 year, okay? Abbreviating. How did we get from 12 to 1? Like, how do we turn a 12 into a 1? We could divide it by 12, because 12 over 12 is 1. Let's think about 24 months. Is 24 months how many years? Kind of thinking, probably comes to the mind pretty quick. That's 2 years. How can we take 24 to 2? Well, we can divide it by 12. 24 divided by 12 is 2. Here's the principle that gives us. If you have months and you want them to be years, you divide them by 12. Keep that in your head. So then back here, when you work all this out, you substitute all your numbers in. By the way, a lot of people miss this 16%.
Pardon the interruption. At this time, please stand for the pledges.
Okay.
I
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now the Texas pledge.
Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible.
Please hold for a moment of silence. Thank you.
The reason why many people make a mistake on this is they put 0.016 because they're used to having a 0 in front of the decimal, but that's actually not what it is. What you have to remember as a smart interest student is that 16% means 16 divided by 100, which is actually going to be 0.16%. So you go down here, you plug everything in, interest equals 565 times 0.16 times, and here's where it gets interesting. How do we turn months into years? You divide by 12. So just write in 8 divided by 12. And if you punch all that stuff out, or if you just run it across your calculator, that times 8 divided by 12, you will get this answer right here. Not that answer. You'll get that answer right there, $60.27. And the total amount for that operation would have been $625.27.
So if you notice here at the top, we still have our same simple interest formula. But if you notice, there are 4 separate values given. And this time, rather than being given a principal, a rate, and a time that we've been given thus far, we are now given an interest. So when you're doing this, we still are going to take each of our numbers and substitute them into their proper place. So up to this point, we've always left our I as has been an I, but now our I is going to be 365 like it is here. So the 365 is going to appear here in our formula. So as we go across, we don't have a principal, so that leaves us with just a P. We're going to leave that as our unknown value. And then when we go 2.4, remembering that we have to take 2.4 and divide it by 100, which will leave us with 0.024, and that will appear in our formula here, times 0.024. And then we still have our time of 3 years. We're not having to work in months right here, but we have our 3 months here, or our 3 years, sorry, 3 years here. So up to this point, you've been able to just multiply across, and then you had your answer. But now we have a little bit of a complex problem that is simpler than it needs. I don't know what I'm saying. It's easier than you think.
You can do it.
You can do it. Okay. So with multiplication, you can multiply any numbers together as long as they are shown to be multiplied. So we don't know what the P is, but we do know that we can multiply 0.024 times 3. My goodness. 0.024 times 3. So once we get that answer, we will find that that number is equal to 0.072 right here, 0.072. So what we're going to do with that 0.072, it's still being multiplied by our principal that we don't know. So what we're going to do is take anything that you get multiplied here and put it underneath our interest, like so. So we took whatever we got here and put it underneath our interest. And then this here on the right, 0.072 divided by 0.072 will give us 1. And we'll be left with 365 divided by 0.072 as 5,069.44 as our amount of principal in the problem.
That's how you do it. Multiply what you can, throw it underneath your interest number. Let's look at this one. Very similar, except now we got to find the rate. So you plug all the numbers in where you can, and this is what it should look like. Boom, boom, boom. Now you're missing the rate. Multiply what you can, which would be that. And then you take that number, which you found, which would be this 20,995. Oops, back up. Which would be that 20,000. Nope, oops, back up. Which would be that right there. And then you stick it underneath there. Do a little division. 425 divided by that. You'll end up with a nice, wonderful mess that looks like that. Except for one thing. That's what your calculator will tell you. But you're smarter than your calculator. Your calculator's not the boss. Your calculator's just a tool. So when your calculator tells you 0.0202 is the rate, wait a second. Rates are supposed to be in percentages, right? They're supposed to have that little wa-boom boom on them. And earlier we learned, and you should be good by now, at the idea of a percentage turned into a decimal. If you're doing that, you divide by 100. But if we're going the opposite way, if we're taking a decimal and turning it into a percentage, then we should probably multiply times 100, and that would leave us with 2.02%.
All right, so we've done two that we've been given different amounts, and this time we're given an interest, a principal, a rate, and we're looking for a time. So as we plug those in, it will be a 532 for interest, a 43,567 for our principal amount. Our rate is going to be that 0.037, and then we're going to be left with a T because that is our unknown that we're looking for here. So again, like Mr. Campbell said, you multiply what you can, which is these two numbers here. And then you're going to then divide those by your interest. It will look something like this. So you're going to get this mess of a number here 1,611 on the right side, and then you're going to divide both sides by that number in order to be left with your time. So right here, once you do that division in your calculator, 532 divided by 1,611.98, you will be left with 0.33 years. 0.33 years. So remember, multiply what you can and then divide by your interest. All right, so that would be too easy, right? If we were just given our principal, our rate, and our time. So sometimes we're gonna have to look at some stories in order to tell what, like a real life example. So this one says, Colton took out a loan from the bank to purchase a car. If he borrowed $17,240 at a simple interest rate of 8.25%, how much total will he have paid after 5 years? So I'm not going to work out the whole problem. I'm going to highlight some key words in order to write our formula. So if we go ahead and if we have our formula, I equals PRT, in our formula, we can go and find those numbers. So he borrowed $17,240. That's going to be our principal amount. We then have a simple interest rate of 8.25%, which will go in our rate category. And we have our time of 5 years, which will go in our time category. So just like before, we have substituting in each of those numbers into our formula. And the only difference here that we have is we're looking for the total, just like on the other problems in that big orange circle, that was the interest that you found. And then in the yellow arrow, we have a total amount. So that is what they're asking you to find on this one.
Super duper. Reset, move on. Number 6. Number 6 is thought-provoking because it actually has extra numbers for you. And the extra numbers are both percentages, meaning this. You've got Citibank up here with that interest rate, and then you've got good old First National down here at that interest rate, and you actually have to compare them, okay? So it's totally doable. You just end up doing 2 problems to get an answer to 1 problem, like so. Tom's in the story, and Tom has $500 to begin with. That's a principal. He's going to be in for 12 years. That's a time. And so what you're going to do is end up building a Citibank side. I'm just going to call it Citi, and the other side is going to be First National. And on the Citibank side, the interest rate is 4.75. On the First National, the interest rate is 3.9%. Okay, you know what to do with that. And then on both of them, it's $500 of principal, and it's 12 years of time. And so you run all those numbers with Citi, all those numbers with First, and then figure out how much more money he would have at Citi. That's how you do that. On this one, let me see. Yep, I just made it big again. On this one, this is one of the ones where you have to find the principal. So just like Ms. Walton did a great job showing us, PRT, and the 150.36 is the interest. That's why it says interest right here. So that's going to go in with your I. The rate is easy to spot, and the 12 years, pardon the colors, but it's right there. It's the time. It's easy to spot, so you have to go through and use your solving process we taught you earlier to find the principal.
So a couple of things that make this one a little bit more difficult, but just like we've started from the beginning, we have our same formula, I equals PRT. So in this situation, we're looking at 72 months, which what you can do is go ahead and divide that by 12, and that is the number that you're going to put in for your time. You can then look at a loan for $35,000, so that is an amount that is being lended to you, a principal amount. And then we have, if Scott paid $8,925 in simple interest. So the only letter that is left is what they're asking for. We're looking for an interest rate, so you can go ahead and rearrange that problem in order to solve it.
Next one may be one of the toughest ones to think about because we're so used to having three numbers. You know, one time we even had four. This time you've only got two. $600 of babysitting and a 5% rate. So in our formula, you've got this one taken care of, the principal, and you've got the rate taken care of, and it doesn't look like there's any other numbers in there, but there are, because this. The question says, how many years will it take to double, keyword, double her initial deposit? Now, we all know what doubling is. If you double 2, you get 4. If you double 4, you get 8, so on and so forth. Her initial deposit was that $600. If you wanted to double that, you would have to get another $600 in interest. So the number that is in the story that is harder to see is actually the interest number, and it comes from the word double. So we're going to take that thinking and put it up in here and say, how much money does she need to make in interest to double her deposit? Started with 600, she can double it by adding another 600. So that's going to go in for interest, the other numbers go in where they go, and then you solve as before. Last one like this. Miles is buying a computer. He's got two options, option A and option B. They got two different interest rates. They got two different terms for the loan. So you just need to go over here, make an A side and a B side, and write the A numbers, which are 10% in 3 years, and the B numbers, which are 6.5% in 5 years. And then you need to use the same principle for both of them. Go in and figure out which one's less, which one's more, and by how much, and look carefully at the answer choices to get that done. Okay, bye-bye to simple interest. Hello to compound interest. Ms. Walton.
All right, so this formula looks a little complicated, but we are going to break down a couple of the letters just to ease your mind. So the P is the same thing. It still stands for your principal amount, okay? Meaning that amount that you're being loaned or the amount that you're putting into an account. The rate still stands, or the R still stands for rate, and that is going to be in a percentage form that we need to turn into a decimal. And this T, if you notice, it is raised a little bit, is actually an exponent, but it still stands for time. And this 1 is just a 1. The 1 always stays there. So what we have different here, we have an A. This A is for a total amount. So as we're solving this, and you can put all of these numbers straight in the calculator, you don't have to make things more complicated because we have access to those handy dandy calculators. So we have a problem here. It says Trevor deposited $1,500 in a bank paying an annual interest rate of 4.3% compounded annually. What is the balance after 6 years? So the different verbiage that they're using, before we were calculating simple interest, but now we're looking at compounded. So that is the verbiage that you're going to look for to know that your formula is going to change to this A equals P in parentheses 1 plus R to the T power. So the same thing as before, we have our different things from our problem, our different numbers from our problem that we can then substitute into our formula. So the deposited amount of $1,500 is going to be our principal, and then we have the 1 in the parentheses that are all going to always be there. And then into our R, we have 0.043, which we see right here. 0.043 is when we divided it by 100. And then we have our time raised as an exponent of 6 years. And when you put that into your calculator, you will end with your total amount equaling $1,931.07. So, looks more complicated, but actually with the help of a calculator, it is easy.
It's going to be so nice. It's going to be so nice. All right. This one, same 3 pieces of information, principal, rate, and time. Plug them in correctly. And when you plug them in correctly, your substitute looks like that. And then when you put them in your calculator, you get an answer. When I say put them in your calculator, just type them in just like that. Like she said, if you need help with that, then you need some calculator help, which is fine. But then you get this number. And this number is good math, but bad thinking. Okay? The good math means you punched everything in right, you put it in right. But the question says, how much interest will he earn? This is the amount. It's not the interest. The interest is how much you gained over the time, okay? How much was added from the beginning. You started with an amount, you added some interest, and now you have a new amount. So to actually find the interest, you have to go take one more step and go up here and say, well, I've got my 2836.70, and then if I go back and subtract what I started with, my $2,400, then I can find the difference between them. You know, difference, subtractions, you know, that thing. So what I got now minus what I started with will tell me that I gained $436.70 in interest during these 5 years. So here's what you need to be able to do at any point with compound interest. If somebody gives you three numbers, like this right here, $1,200 in principal, done. Interest rate, 4.3%, done. Time, 8 years. You need to be able to take that, put it in these spots correctly, like so. Principal goes here. Good, you know that. Rate goes here, 0.043, because we turned it into the decimal. And then the time goes up here in the exponent. And when you run this formula, the answer you get will be the amount. But then you need to be able to go back and find out how much interest was gained every time, because sometimes the question asks for one, sometimes the other, sometimes the difference, sometimes both. It's just, there's a lot of things that can happen with that. So on your TI-89, the way that would run, let me get these in my head real quick, 1,200, 4.3, and 8. So you would go 1,200, then open parentheses, 1 plus 0.043, close parentheses, this caret exponent button, get up there into exponent land, raise to the 8th power, and you type all that in, and you go, I typed it in just like I wrote it, so that means I'm good. Press enter. That's how much money you've got. Now you take this how much money you've got minus what you started with, and you have the two numbers you need. This one is the amount of money you have. That one is how much interest you gained in the course of the story. And you need to be able to do that with any and every set of data points that come into your interest problems, especially with compound interest. Okay? So that's the setup. We went fast. We know we went fast, but that's because you can go back and relook at things if you need to. This will equip you to do everything that we did Tuesday, and no, we didn't have class Tuesday. Everything we did Friday in class, and yesterday in class, and today, and tomorrow, and maybe even into Monday, depending on what we're able to get to on Monday.